Hey guys, what's up? Today we'll be doing rotting oranges. And basically, the question says that you're given a grid, M and N, where each cell can have one of three values, 0 representing an empty cell, 1 representing a fresh orange, or 2 representing a rotten orange. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. That means 4 directionally means top, down, left, and right, and only one of them is good enough to make a fresh orange a rotten orange. And if you cannot really achieve it, just return a -1. So straight away in this a grid type of question, you could see that mostly DFS, BFS are used. You can either use both of them here, like either DFS or BFS. But BFS is easier because we can just first count all the fresh oranges and all the rotten oranges and all their position of the rotten oranges and then store them in a queue. Then we can go inside the queue and then say that um, if the grid, the new direction adjacent, 4 directional adjacent to it, is actually a fresh oranges, then we make it a rotten oranges in one turn, and then we just keep on repeating this process. In the end of the turn, we see if there are any fresh oranges left. If not, then we succeeded. And if there are, then we can return -1 because it is impossible. So a BFS approach is pretty neat here instead of a DFS. DFS is actually more complicated here, and it is generally would not be recommended as well. So for the BFS, let's actually look. So we first discussed that we want to store all the fresh oranges count and then location of the rotten oranges in a queue. So I make a queue, and keep in mind I'm making it as a array, right? A queue of integer arrays so that we can store the location. And then we just have a for loop iterating over the whole um, grid, storing the count of fresh in a variable fresh, and then putting in a queue all the rotten oranges. Now you can just check that if fresh is actually equal to 0, then you can return 0 to handle cases like this that do not have any fresh oranges. That means at minute 0, you can just return because there's nothing to convert. Then we want to do 4 direction adjacent. So we create this direction 2D array, which 0, 1 means right, 1, 0 means going down, -1, 0 means going up, and 0, comma, -1 going left. If you're seeing this for the first time, this is a very neat trick, and people would actually appreciate this in an interview more than you typing out 4 if conditions and being like out of bound checking. That is also acceptable way. This is just a more cleaner way. Then you say minimum equal to 0. That's basically minutes, which is actually not minimum. It's actually minutes. Well, that's why you should have more descriptive variable names. Instead of saying min, say minutes. But I was lazy. Then we'll follow a BFS structure. We're going to say while q.count is greater than 0, that means 1 minute has passed. I can do minutes plus plus. I get the size of the queue, and then I make a for loop. Now, you might be asking, Rohan, why do we need this? Well, you need to do this because if you do not have this loop, then every time you're going to hit this loop and then you're going to do minutes plus plus. So say your oranges are like this, right? So first time you put this orange in here, then this orange in here, and then next time you're gonna put this orange, this orange, then this orange. But then what's gonna happen to your minutes is that this loop is gonna hit and it's gonna say like every iteration is gonna make minutes plus plus, even though it's not actually past a minute. To actually constrain it to like if you have the size in your, if you already have like a rotten oranges, then all of their adjacent have to become rotten. Then you're gonna make a minute go pass. That's why we need this loop. Then inside this loop, I'm gonna say I need an array and I dequeue. Then basically my x coordinate is a 0, y is just 1. Then I have another for loop, which is just calculating new x, new y for this directions. Then I do out of bounds checking. Then I check if the new x and new y is already 2, then just continue. If it's actually 1, then my fresh orange counts can go minus minus. I put this new location inside my queue and I make this as a rotten orange. Finally, after all this while loop is done, I just check if fresh equal to greater than 0, then return minus 1. And then I just say return minus 1, minutes minus 1. So why minutes minus 1? Keep in mind that the first rotten orange was already rotten at minute 0, but we are already making it go minute plus plus for that as well. So to account for that, minute minus 1 is needed. So this is the whole logic for it. First count the fresh oranges, do a BFS, and then make your minutes go up, and then check if fresh oranges are still remaining. If they are, minus 1, impossible, and either return minutes minus 1. So that's the whole logic for this rotting oranges. It's a very interesting problem where you can do it with DFS as well. Much more trickier to do it with DFS. You would have to make your grid start with like you would have to say like 2, 3, 4 minutes so that you account for like if it has already been visited or not. Like it's a little bit more tricky, but this one is much more easier. So yep, this is the solution for this, and that completes our rotting oranges. And the next one we are gonna do was, I found a union find question. I forgot which one was it, but that was a pretty cool question. Okay, I think I remember which question. Maybe that question next. So I'll see you guys in the next video.